So we will see how it goes. Okay, let's go. This presentation is about temporary tables, how you can see what's going on with your temporary tables in your application, and what you can do with that. Something about me. I used to, sometime many years ago, it doesn't work. Why doesn't it go? So we have no presentation, probably. Okay, we have it. So I used to be a Progress employee for many years in the Czech Republic, but I terminated my my contract was terminated in 28, and so now I'm working as a freelancer, as a Progress developer consultant for some of my customers, and also as anyone. There are some hobbies which are, as I'm getting older, which are more and more important for me than the job itself. Yes. Everybody knows what temporary tables are. No problem. I have to say at this moment that this presentation is not about Ferrari. Yeah, it's more likely about Trabant. Who doesn't know what Trabant is? Have you ever seen Trabant? Should I show you Trabant? Okay, let's try to find some. Oh. So this is Trabant. It's not very nice, I understand. It's not Ferrari. You can easily get girls or boys if you prefer, if you have Ferrari, but you can transfer a lot of load. This is a useful car. I know it because when I was a child we used to have one. Yeah. So it's about as I said, it's more likely about Trabant. Originally, Progress in the first version had something like work files. These work files were very limited, only 64 kilobytes just stored in memory, no indexes, so not very useful, but it had some meaning at that time. The temporary table is a later feature, and they are very much like any database table. They are stored in the local DBI file, which has the same format like any data storage area. And in the first version of temporary tables, we had only static temporary tables. Now we have something later on it was dynamized, and we have dynamic tables which can be created at runtime. Their structure can be defined at runtime, and so on and so on. So, as any database, also temporary tables have some limits. As probably the main limit you can reach with temporary tables is the number of indexes. Because any Progress database has a limited number of indexes you can define, and the same is valid for temporary tables. Yeah? You have similar startup options, which you can use with temporary tables, like with any other database table. This is just a short example of them. It's not very difficult. In fact, it's very easy to get this limit. I have a small example here. I can start Progress using Sports 2000 database, open a single procedure. I can run it. and in a couple of seconds, we will get the error. Can you tell me why? Oh, I'm sorry, I have a local version. The error says that we are trying to create too many indexes in the temp table space. Do you know the reason why?
Because the repeat is endlessly.
Yes, I repeat it, but it's not the only reason. The reason is that I'm running the procedure persistently. So I have about more than 1,000 instances of this procedure persistently stored in the memory. And every instance creates its or defines its own temporary table. So my temporary table space gets full very, very fast. One could say that no one would write a procedure like that. But you would be surprised how many times people do that. It's not intentionally. It may be associated with transaction processing. Because if you run a persistent procedure and a transaction is running, then even if you delete the procedure from the memory, it's still stored in the memory until the transaction ends. So if you have problems with your transaction behavior, with your transaction processing, you can get to this limit very easily. Let's go back to the presentation. So this is what I said on the previous slide. Even with static temp tables, you didn't see it, but it was in the code procedure. Even with static temp tables, you can very easily reach the limit because we did not delete the procedure from the memory. And the static temp table is removed from the memory. It's at the end of scope when the defining procedure ends. It's a little bit different with dynamic temp tables. With dynamic temp tables, where you use the create temp table statement to create a temp table, these temp tables are not deleted when the originating procedure is ended. So it's your responsibility to delete it. It can be eventually automated using widget pools. Is there anyone who intentionally uses named widget pools in the application? No one? You? So you know about it probably. Yes, it's a very useful feature. Widget pool, it's such a term which says that if you create some structure, some dynamic structure, whatever dynamic object in a widget pool, then the scope of the widget pool of the object ends when you delete the widget pool. I will show you on an example a little bit later. You can read more about widget pools at the Progress knowledge base. The URL is given. You can see on the slide.
May I have a question?
Yes.
Is that behavior you describe independent from the undo option of the temp table, if you have an undoable temp table or not?
Yes. On my best opinion, yes. The reason is that if a transaction is active, you can have some information in the temp table which you use to undo the transaction. it's not valid for. Have you seen the? I'm sorry, I have forgotten. The question was if it is valid even in case that the temp table is defined as no undo. And on my best opinion, yes. And it's also valid for variables or any other objects. It doesn't differ. What kind of does it answer your question? What kind of resources we can use to monitor temporary tables? We have virtual it's a virtual class, it's a virtual system table for temporary tables, which I will show how we are using class to get to them. We have something what's called TempTableinfo class. We can use log manager. Who is using log manager? Okay, some of them it's a very useful feature. It's not associated directly with temp tables and monitoring. It's a general tool to be used in Progress for logging some statistic. But what's important here, and it doesn't make me very happy, is that you can store only overall statistics, which are collected at the end of the scope of the temporary table. At this moment, I am not available of any tracing possibility during processing, during work with your temporary table, unless you write some 4GL code, which you can use to trace the changes, the operations, creates, deletes, and updates on the on any temporary table. The documentation is very clear about this. As with any Progress database, you can use standard tablestat or underscore tablestat and underscore indexstat tables, virtual system tables, to analyze what's going on with your temporary tables. Yes, that's the documentation, but the reality is a little bit different. It's not so easy, as we will see on a short demo I will show later. It depends when you have a database connected or you don't have a database connected. But it doesn't work in any case. Only the behavior is different. So, I have a short example here. So, can you read the content? So we can see that this is exactly what has been written on the slide. It's the copy of the documentation. I'm using the tablestat ID, tablestat, and virtual system table to get to the temporary tables. And what happens if I run it? I can run it. And you can, I'm sorry. It shows me only database tables, nothing else. Only database tables from the Sport 2000 database. So it shows that it won't be so easy as it seems. So the other example should be if I disconnect the database, I will open the same, and I run the same procedure because the information should be stored in virtual system tables, and it is not there. So as you can see, it will not be, so oh, I'm sorry, I have to translate it to you, unknown or non-unique table name, table stat. It doesn't mean that there are no virtual system tables for temporary tables. It only means that it's not so easy to access them. And I will show some examples how you can do that. So, the approach we have seen is not good enough to do that. So we have to go a little bit further. If you want to work with temporary table virtual system tables, you have to use some very specific startup options. You can see them on the slide. And it's very similar to the base table, table range, base index, and index range startup options, which you can have with normal database tables. So as you can see, it's because of resources, it's very good. We suggest that you should monitor only a limit or only a limited amount of temporary tables, because if you wanted to monitor everything, it would require a lot of memory. And you have a special VST table ID class. It's a class which contains handles to all virtual system tables which are specific for the database, for the local database, for the local data storage area where temporary tables are stored. This class does not have any methods. It has only properties, and the properties are handles to the virtual system tables in the DBI, in the local database for the storage of the temporary tables. So you can see, again, you can see that it's not a complete list of virtual system tables which you can have with temporary tables. There are another, we will see it a little bit later. But again, you can see that this is exactly the same as with normal database tables. Only you have to access it using dynamic queries in dynamic temp tables. Is it clear? So let's go back. Sorry. What's interesting and what we will use in our examples, I will show you examples on the tablestat.id, the tablestat temporary table only, yes? Because for the index statistic, it is the same. There is no specific change. So we will use the tablestat ID property, which is one of the properties of this VSTT table ID class. And we will also use in our presentation another class, is TempTableinfo class, which is both these classes are directly accessible from your ABL code. So in our examples, we will be using ABL code only. There will be no specific command line utilities, no specific features, and so on. So let's go to some examples. The first example will be about static temp tables. It's a couple of, I will close it and open it again. It's a couple of two procedures. VST sample 2 and VST sample 1. In the VST sample 1 procedure, we can define a short temporary table with just 2 columns, and we create two rows in that temporary table. It does, as far as I believe, it is doing nothing. Ooh, it has a lot of functions here. I can see. I didn't know. So this is the way how you can get to the table stat virtual system table. So on this row, sorry, I am getting the handle to the table stat virtual system table. Then this virtual system table has a default buffer. Yeah? And I create dynamic query, and then I go. Creating dynamic query is a process of at least 3 steps. We have to create a query, set buffers, and prepare the query. Yeah. And then you can open the query and you can go through the query. What is this doing? It goes through the table stat virtual system table and displays in the range specified by the startup options, and display the name of the temporary table and the instantiation procedure. In the name of the instantiation procedure. And it is, I run it from this sample 2 procedure, which does pretty much the same. It only does not define the temporary table. So if I run it, I'm running VST sample 1, and it shows me some temporary tables which are defined by procedure editor, by the development environment. I'm not responsible for this. It was created by Progress tools. And standard information which you can get on any table stat ID. So number of creates, number of updates, deletes, and so on. Yeah. So these are the standard, and under number 9 comes my TT table. This is my TT table, and I am still in the sample 1 procedure, where the define query statement was, where the defined table was created. Yeah, so in this procedure, I have the TT temp table still in scope. If I end this procedure, there are no other temporary tables, so I will finish it. Now I am running the sample 2 procedure, and I am getting the same result, and you can see that on number 9 there is nothing, because the temporary table was deleted. The static temporary table was deleted at the end of the procedure. The other example is, I will close it and open it again, with dynamic temporary tables. So it's very similar to the previous one, but the behavior is different. I will open VST sample 3, and VST sample 4. VST sample 4 is pretty much just, which one is it? Yes. It's pretty much the same as the VST sample 2. It just displays the results. VST sample 2 3, I'm sorry, uses, creates a dynamic temporary table. Then there is standard stuff, how to define the structure of the temporary table, prepare the temporary table, and assign default buffer table, and then populate the temporary table from the customer table. That's standard stuff. And then the code is the same. I am going through the list, through the table start virtual system table, and displaying the name and what I am displaying here. Okay, I'm not sure if this were name, data type, and value of the column, and also the table name and the procedure name. Yeah? So, if I run this, I have to run the I'm sorry, I have to restart the session because I disconnected the database before. That's no problem. So in VST sample 3, I have the same results as in the previous example. On position 9, we have our temporary table. Now we are at the end of the VST sample 3 procedure, and we are running VST sample 4. And we can see that we still have, even that the VST sample 3 procedure ended and was removed from the memory, we still have the temporary table in memory. So it was not deleted. Yeah? That proves the statement that that dynamic temporary tables are not deleted at the end of the procedure where they were defined. I will run this. I will run this example again because I will have a question to you. I will run it. And you can see that we still have on position 9 my custom, but on position 10 and next position we have nothing. It means that in the meantime, the dynamic temporary table was removed from the memory, was deleted. Do you know the reason why? I'm sorry? Another suggestion? Sorry? Oh, the procedure and the editor wasn't finished. We are still in it. That's exactly about the widget pool. application builder, or if you run something from application builder or from procedure editor, it automatically places the create widget pool statement before you run the procedure and ends the widget pool when you finish. So when we finished the sample for procedure, the calling procedure, then after that procedure Progress performed called delete widget pool statement, which removed the temporary table from the memory. Is it clear? You can find it in the documentation if you would go there in a detail. I have another option. So if I can go to the end. So if I go to the sample 3 procedure, you can see that there is a command here. I do not delete the dynamic temporary table. So the very simple way how to fix this is that I just uncomment this, and the my table dynamic temp table will be removed from memory at the end of this procedure. If it is not persistent, if it doesn't stay in the memory. Yeah? I have another example here. I'm not going to show you in detail, but just for you to see the code, it's 3A. In this example, I am creating a named widget pool in my procedure, and I create the temp table in the widget pool. And at the end, I issue the delete widget pool statement, which removes the temporary table from the memory. Is it clear? Yes, there's no problem. What would be a good option to do? We could eventually write something like this. Oh, no, I'm sorry, it's not correct. Just this way. So using this finally statement, I can make sure that whenever, from wherever, whichever way my procedure ends, finally the widget pool is deleted. And so all temporary tables created in this widget pool are also deleted. So let's go back to the presentation. Any questions at this moment? Because we have finished some part.
Yeah, I have a question. In the last procedure, you had two commented lines, one with releasing the records and one with deleting the temp table. Is it necessary to release that last record prior to deleting the temp table?
I would say it's a good custom. It's my, I have to say that I do it automatically. I'm sorry, did you hear the question? Yes. Let's talk about the TempTableinfo class now. If you have some problems with your temporary tables, then probably you need just two properties to find some problem. And that's the temp table count property and temp table peak property. If you have some processing and you see that the total or the maximum number of your temporary tables in the memory is still increasing, then there is probably something very, very bad. And you should do something with that. So it's a very simple to insert these two commands into your ABL code. It's just TempTableinfo colon TempTable count display, something like that, and you have it. So we can put it in any log you want. And it's very simple to do. And in most cases, if you have problems with temporary tables, it is here. The overall statistics of the temporary tables are disappear when at the end of the scope of the temporary table. You don't have it anymore. So once you delete your temporary table from the memory, you don't have access to the number of creates, writes, updates, deletes, whatever. Yeah? What you can use another virtual system tables which allow you to store the history. It's just about setting the archive table statistics or archive index statistics property of the TempTableinfo class to true. And then you have access to the table study story and index study story virtual system tables, which contain the information about temporary tables which were deleted from memory, which are no longer in the memory. So even if you delete a temporary table from memory, you can have access to what was going on with them, and but it's still temporary storage. If you finish the progression, even these tables disappear. That's clear. Yeah? So it doesn't solve everything, but it takes us just a little bit further. There are also some methods on the TempTableinfo class. The most important for us is the get VST handle method. We have already used it in the examples. And if the archiving is on, then you can use the get table study story handle or get index study story table method to get the handler to the history temporary tables. If you want to store the information from your temporary tables permanently, then you can use log manager system handle to do that. I sometimes say that you are converting temporary data to permanent data, which is not quite correct, but it sounds very simple. Log manager automatically writes some messages to a log file, and you can also use write message method to write your own messages to the log file. There are some specific startup options associated with log manager, and it's client log startup options where you specify the log file name, log entry types, which is a string of entry types you want to write to the log manager. You don't need to log everything. You just log some. You can just log some events, and logging level. These are startup options. The log manager class itself has some properties and methods you can use. So you can switch between log files. You can say how many log files you have, how big should your log files be. You can also also set the logging level, the non-errors basic verbal extent it is I think 0 to 4 numbers, and the type. What's going on here? I don't know. Let's see. Yeah, and methods, you can clear log, you can write message, and you can close the log. I have an example of the, does it make sense to show you log file? Who doesn't use log manager? I'm sorry? Who does not use log manager? Oh, most of you do. So this is my log file. So you can see that I am collecting statistics on temporary tables. And you can see that I am getting the same information as from the virtual system tables once the temporary table is deleted from memory. So these are the temporary tables from procedure editor, somewhere there. And if we go to the end, we can see here the same data from my temporary tables. We can see here some errors, some application errors. We can also see here some of my own messages. And you can see that today we have 21, and this is from 20. So the log, so whenever you start logging, the log is appended to the previous log. It does not start at the beginning, so you are not losing any data. Writing to log manager is very simple. It's almost like I shouldn't show something like that because it's really very it's something which is very primitive. Yeah. I have an example on that. It's very clear. You just call the write message, write message method of the log manager. But the disadvantage is here that you have to write it in your 4GL code. You have to change your application to get this kind of information. This is some kind of tracing. You trace what's going on the temporary tables. And at this moment, I'm not aware, in version 12.2, I'm not aware of any other option how to trace. maybe with open telemetry in 12.8, we can get some better options how to do that, how to trace temporary tables. I will see when it's when we get the version, then I will see if it's useful or not. But today I'm not aware of any better option. The other interesting question you might have is how big is my temporary table? Doesn't it grow so large? Doesn't it occupy too much space? Oh well, it's like prophecy, like looking in a crystal ball or something like that, because you never know what's on there. But we can have such an estimate what to do. The feature we are using here is the record length attribute to the buffer handle. And we also have access to the number of rows in a temporary table. So I have an example here. I don't know if I am able to identify it here. Let's close this. Open. The nice thing on this procedure is something what's not associated with temp table monitoring, but what's probably a very nice feature. So, in this procedure, I am filling the dynamic temporary table with some data from the customer table in 3 steps. And after of each step, I am displaying the statistics of some statistics of the temporary table. The statistics are displayed by this procedure. The first stuff is as normal. We are getting the handle to the table side virtual system table and going through it. And then we are going through the list of temporary tables. And what is there? What is there? Well, and I have to go a little bit up. I'm going through the list of virtual system tables here, and I am getting the table name and instantiation procedure, because the temporary table is uniquely defined not by the temporary table name, but by the temporary table name and procedure name where it was instantiated. And if I find it, it's not quite clear, because you may have persistent procedures, so you should be more careful. But this is just a simple example. If it's not my temporary table I want, then I'm going to the next iteration of the repeat statement. And if it is that I go through the statistics of the temporary table, I go to the temporary table, counting the average record size, and I am using and I am estimating that the size of the table using the average record size times the number of records. the number of records I can count from the number of creates minus the number of deletes. So if I run it, oh, why doesn't it run? Well, so I can see that in the first step, I have created, I have 86 records, and the estimated size of the table is about 12 kilobytes. Yeah, that's the first iteration. Then, after the second iteration, I have 299 records, and the estimated size 44 kilobytes. And then I will add the rest of the table. I have the same number as in the examples before, and the estimated table size is about 170 kilobytes. Yeah? Okay. Our time is almost off. There will be some minutes for questions, but what's most important, on your opinion, on this specific example? Can you find something very important on this specific, or what you can read from this code? And it's not associated with temporary table monitoring. It's unintentional, but probably the main outcome of this presentation. There is no, to the session handle, there is no attribute like first temporary table and next sibling and next sibling. Oh, I'm sorry, but using the techniques shown in the examples, wherever in your application you can access any temporary table which was created in your progress station, no matter where it was created. If it is in the memory, you can reach it, and you can work with it, you can access data, you can modify it. For sure, if it is table range size, then you have, these are the tables you have access to, because you can get handle to these tables using the source code from the examples, and you can work with these tables. You don't need to pass them tables as the parameters. You don't need to create shared them tables, and so on. So that's all. Any questions?
Should it be a good idea for a process to always create a widget pool? Because by default, to create a class, you have a check mark, but by default it's off. Maybe it's better to be on always, or?
The question is if it is a good idea to use widget pools. Is it correct? Yeah. I would say yes, because it helps you. It helps you. It's a good. It's a good. I would say strategy. It is the same as with the finally statement. Whenever I write a procedure, and I write procedures very often because I like development, the first thing is I create a procedure and I write down the finally statement. And whenever I define a handle, I go to the finally statement and I write, if valid object that handle, then delete object. If you use widget pools, then the good strategy is create widget pool, some name, create temp table, whatever object in widget pool, and then in your finally statement, you can just use delete widget pool. It's very simple.
Can you create multiple widget pools so that you can delete some things but not other things? Would there be a purpose where you would need
Is-
more than one widget?
Is the question if I can create more widget pools in my procedure?
Yes.
I have never tested it, but we have ABL here, so we can run it. We can write a simple procedure. Okay, okay. Create widget pool DD, for example. CC. It runs. Well, we don't, I understand. It's deleted automatically when we return back to procedure editor. Yeah, so I didn't write the delete widget pool statement, but it runs. So definitely it doesn't work, it doesn't answer your question completely, but it seems to run. Okay, just one more question. Okay, if there are no any more questions, thank you very much for listening to me.